All right, guys, so I wanted to take some time and make a video for you that will go through the quiz that you just took. You don't have to watch the whole thing, just watch the parts that you missed. My hope is to be able to go through and talk through each of the questions, show you how to use the calculator on some of them. I know that there were some issues with not knowing how to use the calculator or mixing things up, so I want to make sure that you have access to that. Please do make sure that on the calculator questions you are using the calculator, okay? There are, yes, other ways to do it, but most of the formulas are not given to you in the formula packet. The only one that's given to you is compound interest. So when you get to those, make sure you're learning how to use a calculator. If you don't have a calculator with you, please send me a message and let me know so that I can help you out. All right, so here we go. SL Exponential Modeling Quiz, question number 1. First four terms of a geometric sequence are 2, 5, 12.5, 31.25. So first, find the common ratio. Of course, the easiest way to find the common ratio is to take any term and divide it by the previous term. Okay, and this is one way to write that, un plus 1 divided by un. Another way that you can write it is un divided by un minus 1. Okay, so that's any term divided by the previous term, or like this, any term divided by the previous term. So that's what we're going to be doing. Well, you can do that with any of these numbers. You can show that if I have 5 divided by 2, I get 2.5. So that was the second term divided by the first one. Okay, I can also do the same thing if I do 12.5 divided by 5. That will also give me 2.5. And I can do it with the 31.25 as well. So you can show, even if you didn't know it was a geometric sequence, they did tell you it was a geometric sequence, but even if you didn't know, you could show that it was by doing the two, each one of those, 5 divided by 2, 12.5 divided by 5, and so on and so forth. So we've got our common ratio, which is 2.5. The question now asks you to find the eighth term. So to find the eighth term, we're now going to use our formula, which is that un equals u1 times r to the n minus 1. And this is in your formula packet. It's in section 1.3, SL 1.3 in your formula packet. You should be able to get that. That's for a geometric sequence. And then you should be able to go that un equals the u1, which is the first term, which they gave us is 2, times r, which was 2.5, to the n is the term number, so 8 minus 1. You should be able to put that straight into your calculator, and we should get 1220.7. Okay? On an IB exam, it's likely that they're only going to want you to write it to 3 sig figs. So 1220 would be an appropriate answer there. Okay? If they ask for something else, then of course do whatever they ask for. Okay. Next is find the sum of the first 8 terms. So now we're going to be doing the sum. Most of you got this right, but I figure I work through it just in case. Sum of the first 8 terms means that we need to be adding all of them together. Again, this formula is in your formula packet. There's 2 of them. I'm just going to go u1 times r to the n minus 1 all over r minus 1. And go ahead and put that in for the first 8 terms. Then it's going to be equal to u1, the first term, 2 times the constant ratio, 2.5, to the n, which is 8, because there are 8 terms, minus 1, all over 2.5 minus 1. And I got about 2033.2, which again, if you're writing that to 3 sig figs, then you should write 2030. Okay, and that would be correct to 3 sig figs. Again, for now, if you don't want to worry about that, then it's okay to write the 2033.2 is enough. All right, that's good for now. Let's move on to the next question. Question number 2. In a research laboratory, biologists studied the growth of a culture of bacteria. From the data collected hourly, they concluded that the culture increases in number according to this formula, where n is the number of bacteria present and t is the number of hours since the experiment began. All right, so we'll go ahead and work through this. We're going to answer each of the questions as best we can. And question number 1 says find the number of bacteria present at the start of the experiment. So the start of the experiment, of course, means that T equals 0. So we go ahead and put that in. So for part A, we're going to go N0 is 35 times 1.85 to 0. And you can put that into your calculator if you want, or you can recognize that anything to the 0 power is 1, which means that we'll have 35 times 1, which is just 35. Okay, be careful that you don't just cross this out. Recognize that you cross it out and it becomes 1, because anything to the 0 power is 1. That's something that I've seen students have a difficult time with later on, and they end up canceling it out, and it doesn't actually give 0. It actually gives 1. All right, let's go ahead and look at question B. Calculate the number of bacteria present after 4 hours. Okay, well, T is the number of hours, so we're going to put 4 hours in for T, and we're going to go N of 4 equals 35 times 1.85 to the 4th, and when we do that, we should get our answer of 410. Now, I know some of you got 409 point something something something. Be careful that these are bacteria, right? It's not millions of bacteria, it's not thousands of bacteria, it's just actually the number of bacteria. You cannot have a decimal number of bacteria, okay? Now, some of you may say, well, if it's 409 point something something something, should it be 409 because the next one isn't there yet? That's fine. They will also accept 410. They're going to accept 410 because the 35 here is only 2 sig figs, which means that your answer technically really should only have 2 sig figs. And so 410 has 2 significant figures there. All right. So there you go. That is letter B. Please make sure that you don't put a decimal or fraction number of bacteria or rabbits or people or anything else. If it's money and the decimal makes sense, go ahead and put it there. If it's height, the decimal, if it's something that's continuous like that, where you can measure it and get a decimal height or a decimal time, then it's fine. But you have to make sure that if it's a thing that is discrete, that can only have a certain number of occurrences, that it can't exist in fractions or decimals. Okay, so be careful with that. All right, letter C says calculate the time it would take for the number of bacteria to exceed 1,000. Okay, so we go ahead and put in for C, and we want the number to be bigger than 1,000. So we know that 35 times 1.85 to the T is the number that we get. We want that number to be bigger than 1,000. Now, of course, you can just put that in and you can calculate T with an equal sign there on your TI-nspire. Doing insolve is the easiest way to do that. You don't need to show the algebra using logarithms and things like that. Of course, you're welcome to, but I don't think that that's the best use of time usually. So what you should end up getting is that you get exactly 1,000 when T is equal to 5 point, I'm going to round it to 3 sig figs, 5.45. So therefore, I was not very harsh on this, but your answer should be that T is greater than 5.45 hours. Okay, you do need the inequality because it says calculate the time it would take to exceed 1,000. Well, any time larger than 5.45 would be larger than 1,000. Okay, so that's letter C. Let's move on to letter D here. So letter D, we've got due to the amount of nutrients available, the culture cannot exceed 1,000 bacteria. State the domain of the function. Well, we know that the number of bacteria started at 35. That's what was given in the beginning. So that's the lowest. And then it's allowed to go up to 1,000, right? Now, that is not the domain, that's the range, right? The range is that N can be anywhere between 35 and 1,000. It can be equal to because it says it can't exceed, but it can be equal to. All right, so this is the range, and I think a couple of you put that down. You do need to talk about the domain, which is the time that you're allowed to have. And so the domain would be the x values, everything from time equals 0, and yes, time can be greater than that. Make sure that when you put your inequalities down, this shows that time is bigger than 0 because the alligator sign is eating the t instead of the 0, to put it in 6th grade terms. And then t is also less than this time right here, 5.45 hours, because at 5.45, that's when it goes over. Okay, and it should be less than or equal to. I believe if you look up a key, it has less than, but it does say that it can't exceed 1,000. And at 5.45, it hasn't actually exceeded. That's when it is at 1,000. So that should be fine. All right. Okay, that's question number 2. Let's move on to question number 3. A company is considering a new product. The new production requires the installation of new machines and equipment. For this purpose, the company wants to borrow money by selling bonds, each priced at US $100,000, lasting for a 10-year period. The interest which the company pays to the bondholders is 5% per year. Calculate the amount of interest to be paid per bond over the 10-year period in each of the following cases. Give your answers correct to 2 decimal places. All right, now the first one, I don't need my calculator for. The first one is simple interest. Now remember, simple interest, the question is I need to take the initial amount, the principal, and then I'm going to, so this is part A, I'm going to take that principal and multiply it by the rate, the percent, and then I'm going to multiply that by the number of years, right? Okay, now what this does, the principal times the percent will give you how much interest you get each year. All right, then the n is times the number of years. So what I actually get here is the amount of interest. And most of you are okay with that. We go ahead and put the 100,000 in for the principal. And then we multiply it by the percent, which is 0.05. And then we multiply it by our 10 years. And we get a total of 50,000. Okay, you do have to be careful here because the question, and a couple of you missed this, it says calculate the amount of interest. So we just want the amount of interest here. We're not interested in the total amount that they have to pay. That could be a different question, but here it's just asking for the amount of interest. All right. Okay. Letter B, interest is compounded annually, and then letter C, interest is compounded monthly. Now, at this point, I'm going to refer you over to the calculator because, yes, you could do your formula here. You could do the compound interest formula, which is in your formula packet, but I'm going to encourage you to use your calculator here, and I'm going to teach you how to use that. So follow me over to the calculator. We'll do that, and then we'll come back and work some other questions. All right, here we are. We got my fancy teacher calculator on my computer here. I'm going to show you how to use the TI-nspire to answer some of these financial questions. All right, right now we're working on question number 3 from the quiz. Okay, this is a simple annual compound interest question. Okay, so just in case you hadn't found it yet, you want to go to menu here, and if you look over on the left-hand side of the screen, you've got my calculator. So I'm going to menu. All right, in menu, you're going to go to number 8, finance, and then the finance solver. All right, so that's what we're looking at. Okay, now it does give you some helps down here at the bottom of the screen. It says number of payments is n. So it should help you as you're going, right? Now this first question was a company that over 10 years was doing bonds of $100,000, right? So over 10 years, if I'm compounding annually, then it will be 10 payments, right? The percentage that I'm paying out is what's given. They say that it's 5% per year. So I'm just going to put a 5 there. Okay. Now the present value for the company, they've gained 100,000, right? So I'm actually going to put 100,000 there, right? Because they've actually gained that money. Now the payment, they're not making any payments on this. Okay. The future value is what we're interested in. Okay, that's the FV. So payments is like if you're making monthly payments on a loan or a amortization or annuity or something like that. We don't have to worry about that. The future value is how much it'll be worth in the future, and that's actually what we're looking for here. You've got the PPY, which is the payments per year, okay? And then you've got the compounds per year, and in this case, letter B is just compounding annually. And so we've got that, and the payments are going to be at the end of the year, unless it specifies. Don't mess with that. Okay, so what we want is we want to know the future value. So we go to that, and notice that it says push enter to calculate. So I go there, and I push enter, bloop, right there. So it's negative because I'm looking at this from the company's perspective, right? It gained $100,000 when it sold the bonds, okay? But in the future, it's going to have to pay back, or it's going to lose 162,889, okay? Now, in terms of the question was how much interest is going to be paid. Well, you take this number and take off the 100,000 that they gained initially, and you get 62,889.46. All right, so that's going to be part B. We're not going to go right back because part C is just compounding monthly. Now, because I'm getting paid more often, there's two ways to do this. One is that you can simply go down here and change the compounds per year to 12. All right, now if you do that, it's still going to have the 10 years. All right, it's still going to have the 5% interest rate, right? But it's going to take care of, this works if you're dealing with the compounding. This will automatically take care of those 12 compounds per year. Now again, what we want is the future value, so you can go to the future value here, and you just push enter, and it recalculates it for you, and you get 64,700. Which is the correct answer, okay? Again, yeah, it would be 701. If you're writing it to 3 digits, then it's just 647. Remember, we're taking off that initial 100,000 because we're looking just for the interest, okay? Now, I told you there were two ways to do this. If you don't want to have to worry about the compounding down here, you can leave that as 1, okay? You can go up here and you can treat it, instead of 10 payments, which is getting compounded 12 times during that process, you could just change this to, and this is what a lot of you did, is you said, well, that means I'm going to have 120 different compoundings, right? 12, and you can actually just do this. You can take your 10 years and say, I'm going to multiply that by 12, because now I'm going to get 12 times as many payments. Now, if you do that, you do have to change this to 5 over 12, right? That means that each time you get interest is going to be that 5% divided by 12. Now, if you do that, you could go down here, and I'm just going to change the number real quick just so that you can see it is going to still give me the right answer. You go down to the future value, and you push enter, and once again, it gives you the same answer, which is 164,700. Again, you take off that 100,000 because that's not the interest, and so the interest is 64,700. All right, so that's how to use the calculator for that question. Either way is fine, as long as you are comfortable and you're consistent with your convention. All right, now let's go back to the quiz paper so that we can answer some more questions. So here, for part B, you saw on your calculator that you should end up getting 62,889.46. That's the total amount of interest, okay? Letter C, you should get 64700.95. Okay, these are both from the calculator. Make sure that because this is dollars use cents as well. That's why I've gone to this decimal place. I've gone down to the hundredths place because that's how cents work. Okay, you probably should be aware of that for US dollars. You know, a lot of types of money you don't have to do that, but for US cents you do need to. For euros have cents, right? And so be aware of that. Those are common types of money. You don't need to know every single type of money, but you should be aware of some of the most common types present, and so be aware of that. Okay, on to question number 4. A large city is concerned about pollution and decides to look at the number of people using taxis. At the end of the year 2015, there were 50,000 taxis in the city. At the end of the nth year after 2015, the number of taxis in thousands is given by 50 times 1.1 times n to the n minus 1 power. Find the number of taxis in the city at the end of 2020. Okay, now a couple of people missed this one because they just didn't read the question close enough. It's actually defined right here. It says at the end of the nth year after 2015. Okay, so at the end of the fourth year after 2015, n would be 4, right? So 2020 is 5 years after 2015. You can count them off on your fingers if you need to, right? But 2020 minus 2015 is 5 years. 5 years would have passed. So at the end of 5 years, that means n equals 5. That's what's going to go into our equation. So the number of taxis in the city at the end of 2020 will be 50 times 1.1 to the 5 minus 1 power. Okay? And we should get about 73.205 thousand taxis. Okay? Now, realistically, our answer should be about 73.2 thousand taxis. All right? Because likely on the IB exam, they're going to ask you for 3 sig figs. Okay? Let's move on to part B. Assuming that the model remains valid, find the year in which the number of taxis would double that what it was at the end of 2015. So we know at the end of 2015 there were 50,000 taxis. So we just need to find the year when the total number of taxis is 100,000. And so we're going to go 100 equals 50 times 1.1 to the n minus 1 power. And we should then be able to solve for n. Now when you solve for n, you end up getting 8 point something. Okay, and I'll let you figure that out on your calculator. Most of you got to that point, okay, but you get 8 point some number. Okay, now when you get that 8 point some number, you need to recognize that 8, if it were just 8, then it would be 8 years after 2015, which would be 2023. But the reality is, and remember, this is talking about at the end of the nth year. So 8 would be at the end of 2023, which means if I have more, that means it's now gone into 2024. Now, some questions do count starting in January when the year starts. But this question specifically says at the end of the year, and so you do have to pay attention to the word problem and what details are being given. And so the answer here will not be 2023, it will be 2024, because it's in that 9th year. After the 8th year, a little bit longer, right? That's when you will end up with double the number of taxis, 2024. All right, on to question C. At the end of 2015, there were 2 million people in the city that used taxis. N years later, the number of people in millions that used taxis was given by 2 times 1.01 times to the n minus 1 power. Assuming the model remains valid, find the number of people who used taxis at the end of 2020. So again, the number of people that use taxis, so people is going to be equal to 2 times 1.01 to the 5 minus 1. And so then we should be able to calculate how many people, which in this case we get 2.08 million people. Okay, and notice that I did use the 3 sig figs here, so 2.08 million people. And we can then go on to letter D. Again, recognize we put 5 here because it's 5 years after, and so n is the nth year after 2015. R is the ratio of the number of people using taxis to the number of taxis. Okay, so people using taxis over number of taxis. Okay, so the common rate, find the ratio at the end of 2020. Well, they've had us calculate those two numbers. They had us calculate the number of people, which is 208 million. So that would be 208. I'm going to put the commas in there to make sure that's the right number of people right there. and then there were 73.2 thousand taxis. Okay, now if you have a better number than this, you can go ahead and put in the real number here. You really should use the correct numbers. When you're writing the answer, it's 3 sig figs, or whatever they ask you for, the proper number of significant figures. If they don't, when you're working out the problem, you should use the correct numbers. I don't have those numbers in front of me right now because my calculator is on my other computer, but I would like for you, if you have these numbers, to use those numbers. Same thing here. It'll be 73,205 because it was 73,000 taxis. And so you do 280,000 divided by 73,205, and you should get something like 28.42. And again, 3 sig figs is fine, 28.4. I'm getting an extra one here just so I can show you what hopefully you are getting. Okay, so we found that the ratio is 28.42 people to one taxi. And that is letter D. Now letter E says comment on the values of R in 2015 and 2020 and what this means for the city planners. Well, it asks for a comment and what this means for city planners. You have to remember the beginning of the question is a large city is concerned about pollution, right? That's why they're looking at the number of taxis. Your answer needs to refer to the large city being concerned about pollution. All right, so thinking about that, back in 2015, I had 43 people per taxi. Now I have 28 people per taxi. Now, does that mean that it's easier for people to get taxis? Yes, because there's less people per taxi, but that's not answering the question that's being asked. The question being asked is regarding pollution, right? If I have less people per taxi, that means that there are more taxis. I have almost 30 people using one taxi, whereas I used to have 40 people using one taxi. Can I decrease the number of taxis such that I have 40 people using each taxi again? Decreasing the number of taxis would then allow me to have less pollution. The other way to do it is you could encourage people to use taxis, because I could handle 43.6 people per taxi before. So maybe I encourage more people to take taxis instead of using their own cars. Maybe the taxis are more efficient, or maybe, well, at least right now, the way that the taxis are working, the taxis are running around a lot of time without people, obviously, less than before. And so you need to be referring to something about the pollution and how this connects. All right, so that's question number 4 for you. We are going to move on to question number 5, because we can. All right, Emmy and Elisa go to the Jingshan swimming pool every day after school. They both swim the first length of the pool in 2 minutes and 6 seconds. Congratulations, ladies. The time it takes Emmy to swim each following length is 5 seconds more than the previous length. The time Elisa takes to swim each following length is 1.04 times the number of the previous length. State the time Emmy takes to swim the third length. Now, really what I want you to be recognizing here, because this is going to be important in the later steps, is recognize that if Emmy adds 5 seconds every time each length takes 5 seconds more than the previous one, then what that means is that Emmy, her times are following an arithmetic sequence. Okay? Now, I know that you could just take 2 minutes and 6 seconds, add 5 seconds, and then add 5 seconds again to get the 3 laps, and you get 2 minutes and 16 seconds. You can also use your arithmetic sequence, which is UN, and I want the third length here, equals U1 plus N minus 1 times D. So I want you thinking about this in terms of the sequences. You don't have to work it out this way, but in a more difficult, complex question, it may be necessary. You wouldn't be able to just go plus 5, 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 right? So my first term is 2 minutes and 6 seconds. Now, one thing I want you to recognize, and a few of you made this mistake, 2 minutes and 6 seconds is not 2.06 seconds. Okay, this is the decimal system, which means it goes up to 100, right? The 6 goes up to 10 before you carry 1 over, and then you get 2.10, and then that goes up, and that goes up to 0.2, then 0.3, all the way up to, but it doesn't stop at 6, right? The seconds, however, is on a, I forget what it's called, a hexadecimal system or something like that, where it only goes up to 60, right? It doesn't go up to 100. So therefore, you can't just go straight from this to that. They're different bases. It's actually quite related to our exponents and logarithms, but we're not going to go into that right now. So if you want to turn it into a decimal, then this 6 is 6 seconds out of 60 total seconds, and then you could turn that into a decimal, which you could then put in here. Now, is that what I recommend? No. I recommend that you just take the whole dang thing and turn it into seconds, because then you have to worry about any decimals at all. Well, until later. A minute is 60 seconds, so 2 minutes is 120, so add the 6. This is 126 seconds. Okay, so that will be much easier in this scenario. Same thing if you have hours, right? You turn hours into minutes and deal with the minutes. Same thing if you have days, right? You can turn it into hours, right? Work with numbers that are going to be easier without having to make those conversions between 60ths and hundredths, all right? So we can go ahead and do that. That means U1 is 126 plus, and then I want the third length minus 1 times the constant difference, which we said it's adding 5 every time. And so then you should get your answer of 136 seconds, which is 2 minutes, 16 seconds, right? Subtract off 60, and then you've got your 16 seconds left over. The next question says, show that Elisa takes 2 minutes and 16 seconds to swim the third length. All right. Well, some of you said, well, did you mix them up, Mr. Bywater? I think Emmy took 2 minutes and 16 seconds. Well, let me show you. So does Elisa. Okay, so each one of these is 1.04 times the time of the previous. So that should be a ding, 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 that it's geometric here. Okay, so this is a geometric sequence. And so we'll be able to use UN equals U1 times r to the n minus 1. And so we should be able to put that in. We do want the third one. Again, I'm going to put it in seconds instead of putting it in minutes and decimals and things like that. So I'm going to go 126. That's my 2 minutes and 6 seconds for the first length, times r, which would be 1.04, okay, to the n minus 1 power, so 3 minus 1. When I work this out, I get 136.28 seconds, which then I need to take the time to say that that is equal to 2 minutes and then 16.28 seconds. And that is about 2 minutes and 16 seconds. Okay. Anytime it says about, you need to make sure to show at least 1 or 2 more digits and show that your final answer will round to that about. You can't just get to this point and say, oh yeah, it's 136. Okay, you need to show these extra digits. That's just one of the things that IB wants. They want you to show that you actually got to the right number, and then they're giving you an about just so that you can say, ah, yeah, I got it right. Okay, if you are not getting what they say it should be about this, and you're not rounding properly to that number, then there's a problem. You should go back and fix your work. It's not that the problem's wrong. It's that you need to go back and fix your work. Yes, Mr. Bywater makes lots of mistakes, but this was not one of them. All right. So we've done A and B. Let's move on to C. And the last part of this question asks us to compare the total of 10 lengths of the pool, right? And this, unfortunately, is what a lot of you missed, was that it's asking for the total of 10 lengths of the pool. All right. Now, this is where it's going to be important that you recognize before that you had arithmetic and geometric, because initially, right, it was possible to just kind of add or multiply to get the answers to letters A and B. But in order to do this, it's going to take you way too long if you try to do it that way. All right. So what we need to do here is first we're going to work with Emmy. Okay. Now, Emmy was arithmetic. And so we need the sum of the first 10 lengths. All right. Now, there are 2 equations for that. but we are going to use the first one, the Sn equals n over 2 times 2u1 plus n minus 1 times d. The reason why we're doing that is because the other equation requires you to have un, and un here would be the 10th length. Now you can, and I saw some people do this, I saw some people calculate the length of the 10th lap, the 10th length, and then you use the second equation instead of the first one. If you do this one, it'll be a little bit faster and quicker. You know you're going to go 10 lengths, then 2 times u1, which is 126, plus, and then n, which is 10, minus 1 times d, which is 5 seconds for each lap. And then you should be able to work out the answer to that, and you get 1485 seconds. Now, if you want to turn that into minutes, that's fine. It's a little more than 24 minutes, almost 25 minutes. You can do that if you want, but it's not actually necessary here because we just need to be able to compare the two, right? So now we're going to look at Elisa, and so she, remember, was geometric. Again, we've got a formula for this, right? We've got a formula for geometric, which is the Sn equals u1 times r to the n minus 1 over r minus 1. Again, like I say, you can use the second equation. That one is less important, whether you use the first one or the second one, because they have exactly the same variables. But we go ahead and put it in. We put 126, and then we go rn, which would be 1.04 to the 10th power minus 1 all over r, which is 1.04 minus 1. And we put all that together, and her time would be about 1513 seconds. So this is a little bit less. Make sure that when you're doing these calculations, you're keeping all the digits from the previous parts. Okay, this is slightly more than 25 minutes, which of course then leads us to the conclusion that Emmy is faster than Elisa there on the total of 10 lengths. Not by much, right? If you were to subtract these two, you would find out that it's about 28 seconds. 28 seconds. So not too much, about half a minute, but there is a difference between the two times. All right. Long decides to take a loan of 20,000 RMB to buy a fancy new VR system. His bank offers two options to finance the loan. Option A is a 5-year loan with an annual interest rate of 12.8% compounded quarterly, no initial deposit required. And option B is a 5-year loan with an interest rate of 4% compounded monthly. Terms of the loan require 10% initial deposit and a subsequent monthly repayments of 400 RMB. All right, so we're gonna again go over to the calculator so that I can show you a number of things, and then we will come back to this in just a moment. All right. We are looking at long, option A, so this is part AI, and we're trying to find out what is the repayment that he makes each quarter. All right, so in order to do this, we're going into our menu. We'll go to Finance, Finance Solver. Okay, I've still got the numbers in there for my previous question, and that's perfectly fine. It's not going to mess anything up. All right, so now I need to determine how much he needs to pay each quarter. All right, so one way to do this is say, well, he's going to need to make 20 payments, right? Because it's 5 years. 5 years, each quarter means 4 times a year. He's going to need to make 20 payments. All right. Then I'm going to go down to the percentage, okay, the interest percent. And the interest percent is 12.8 per year, or in other words, 12.8 divided by 4 for each quarter, right? And it calculates that for me. It's fine. It's this calculator smart. The present value is he took a loan of 20,000 RMB. Okay, so that's how much he took in the beginning. And then he needs to figure out what his payment is going to be. We do want the future value to be 0, right? We want him to owe 0. We're looking at how much his payment needs to be. Okay, now because I've set this up as 20, right? This is 20 individual payments there, right? Once each quarter, all right? Then when I go down to this payments, I'm only going to do one because I've identified N as being a quarter, right? And so only one payment for each of those quarters, right? And so I go in and I should then be able to say, well, what will his payment be? I push enter and I get 1369.29. All right, and that is the correct answer. All right. Now, for those that are interested, I'm going to show you a second way to do it. I can go in here. I still want to make 20 payments, so I'm going to leave that 20 payments the same. All right. Now what's going to happen is I'm going to change my interest rate because it is 12.8 per year, right? So I'm going to think in terms of years now, but I still need 20 payments. It's a little bit different on these questions when you're making or getting payments throughout the year. You can't, it's a little bit more difficult to do in this manner. Okay, so I'm going to leave that yearly percent as 12.8. Okay, I'm going to delete some of this just so you can see it actually works later. I still want my present value to be 20,000. I still want my future value to be 0. But here, I'm going to make note that I want to make 4 payments per year, and I want it to compound 4 times per year. All right. Now, that compounding is going to be in association with this percent here. So that's why that needs to be that way, because it's automatically going to take care of that. Okay. Now, the payments per year, because that's 4, you'll notice I had to leave this at 20. The reason being because this is N, the number of payments, right? And so that's why that's going to have to be 20 there. Now, you'll see when I go to payment here and I push enter, I get the same 1369 that I got last time when I did it the other way around. All right, so that is Long's option A, and the repayment that he makes each quarter, 1,370. Notice that it's negative because he loses money for each of those payments. He's got to pay it out, whereas the present value is positive because he gained that money. Okay, this is a convention. I've mentioned this a couple of times on Teams and in videos, but this is the way that it kind of makes sense, that every time you do it, you can make those connections and make those links. All right? All right, so in that question, we then calculated the repayment he made each quarter, which we found to be about 1369, and I've rounded that to the whole just because that's really what we do use in China. I suppose you could put a decimal there. It is RMB, so you could round it to the 10th place because of the jiao, but I think this is probably fine, and that was the repayment each quarter. So then to get the total amount he would pay over the 5 years, you take that, you multiply it by 4, because this is each quarter he needs to pay 1369, so multiply it by 4, that'll give you 1 year, and then you multiply that by the number of years, which is 5 years, and you should get the total, which then would be 27386. Now this number comes from using the full decimals. Okay, like I mentioned before, you can write the answer as 13.69 if you'd like, but when you work any other part, like when I multiply by 4, multiply by 5, I need to use the full decimal in order to get the 27386 RMB. All right, and then the last question, of course, is what is the total interest he pays on the loan? Well, the loan was 20,000. I end up paying 27,386. So subtract the 20,000 and you get 7,386. So that's the amount of interest we pay. For letter B, we're also going to use the calculator, but first we're going to do part I. Part I asks for the total amount he pays to the bank. So the total amount he pays to the bank, well, it says he does subsequent monthly payments of 400 RMB after a 10% initial deposit. So the 10% initial deposit is 10% of the 20,000. So 10% of 20,000, do 0.1 times 20,000. So that will be the deposit. And then it says he pays 400 for the next 5 years. So that's monthly, right? So 400 times 12 times 5, so that would be per year, and then 5 years. And we put all that together, we multiply it out, we add it up, and we should get 26,000. Okay, now we're going to use that number. That is the answer to letter I. That's the total amount he pays the bank. We are going to go to the calculator to find the annual interest rate. So follow me over. We're trying to figure out Long's option B now, right? So we're going to go up. Instead of 20 payments now, he's now doing it for 5 years, right? But he's doing monthly now, and he's making monthly payments. Okay, they have made it a little bit easier by making it both monthly. All right, so instead of 5 quarterly, it's now 5 monthly. So 5 times 12. Okay, the percent we don't know, so I'm just going to leave it for now. The present value, he actually only needed to take 18,000, right? Because he's already paid 2,000, and so now he's just borrowing 18,000, right? And then that's gain. Now we know that his payment is going to be 400. So I'm putting in negative 400 because he's actually paying that. All right. And then we've got our future value, which we want to be 0. And here, because I put in the interest being 12 point, I'm looking for that interest. We're going to put in 12 payments per year and 12 compounds per year. So this is like the second way that we did option A earlier, right? I want it to compound 12 times a year. I want to make 12 payments per year. Now, if I do it this way, the percentage I get here should be the percentage for the year, because I'm not looking at individual months, I'm looking at the full year. Even though I am making 60 payments, I'm still looking at for the year. So if I push enter, I should get, look at that, 11.95, 11.96 actually is the percentage that his interest rate is. All right. There you go. The other way, of course, that you could have done this is you could have said, well, what if I think about this in terms of months, and so I go 1 and 1, so 1 payment per month, 1 compound per month, and you'll notice that if I go here and calculate the percentage, I get 0.996. And you may say, well, that's not right. Well, that's per month now. So if I go 0.996333 and I multiply that by 12, I get 11.96, just like I'm supposed to. And you can see that right here on this screen. Sorry, I'm not using the other stuff. So anyway, there you go. You've got 2 different ways to answer the same question, and then we're going to go back and answer part II and then letter C. So let's head on back. And we're back. Now that we're back, of course, we can answer the following question, which is state which option Long should choose, justify your reasoning. Well, obviously option B costs less, right? He's going to spend almost $1,400 less if he does option B. You should have the caveat that is if he has the money to make the deposit. Remember, the deposit here was 2,000 RMB. And if he doesn't have 2,000 RMB right now, then he can't do option B. So I would definitely say 2 things. I would say he should choose option B, but that is dependent because he saves almost 1,400 RMB, but that is dependent on his ability to pay the deposit. If he can't pay the deposit, then he needs to choose option A, and that would be my answer to letter C. All right. Okay, that's the end of the quiz. Hopefully that was helpful. Make sure that you get comfortable with the calculator stuff and that you understand how to work through that.